Hey guys, welcome to PreCal. My name is Highland Turby. I'm your CTL. My email address is on this first page. You are welcome to email me any questions you come across within this unit. Unit 1 is characteristics and applications of functions. This unit is laying the foundation of function analysis using patterns. We are going to go through the goals of this unit, our unit projects, our approaches to learning, our unit assessments, and our daily lessons, so you have a good overview of what this unit entails. So our big goals for this unit are for students to be able to apply their learning to recognize and apply patterns to real-world problems. This is tied directly to our unit project, which we will look at in a few minutes. The second goal for our unit is for students to be able to apply their learning to analyze graphs of real life functions using their insights to help make informed decisions about those functions. This ties directly to the function characteristic analysis that we're going to go through in the second part of the unit. So in stage 1 of our unit plan, we see inquiry questions. These questions are based on our pre-cal content. They go from the lower Bloom's type of questions up to our higher Bloom's questions, where they are asked to make decisions about what they have learned. So if you look at the factual questions, we ask them to define what a sequence is, how to find a common ratio and what it means to have a common ratio, what does it mean for a function to be increasing or decreasing, what is a function, what is domain. Some of these questions are spiraled back in from previous years, but it's very important for students to always keep it in the forefront as we're defining our function characteristics. Our conceptual understanding and questions for this unit really tie together two concepts: characteristics of functions and, of course, our sequences and series. We want the students to be able to understand, for instance, how an individual function characteristic is demonstrated in the table, graphs, and symbols, our three representations. We also want to look at how a function might be defined differently or similarly to other functions, and if those characteristics are the same, and also what's the difference between defining a sequence recursively and defining a sequence explicitly. So keep these questions in mind as you go through your planning process and make sure that you can include them. These are good questions to use as checking for understanding within the unit or a daily lesson. They can also highlight where you might need to go back and reteach. Our debatable questions are towards the ends of each section of the unit. Is there a right way to model a relation or a function? That's something that students might need to debate and understand how to use the function characteristics that they have learned. Can patterns and sequences be seen in function characteristics? So tying the two parts of this lesson that seem separate, they can be tied together using these questions. Can, in fact, patterns be used to inform real-world situations? That's also a really good question to bring up with your students as you're going through this unit. Now, within this unit, we're looking at specific TEKs. You'll notice that we have a significant number of TEKs that we'll be covering. The bolded TEKs here basically outline our priorities, and the non-bolded TEKs are essential TEKs, but they're not as highlighted or defined when we're talking about on the assessment or within the project itself. So make sure you look through these TEKs and that you're using them effectively and getting through each daily lesson. Now, our essential knowledge and skills, this is defined what students will know and how they'll be skilled at using them. Notice that they are asked in questions of how are they going to use summation notation, how to find the sum of a sequence using algebra and a graphing calculator, how to define parent functions and their characteristics and which characteristics are defined each one, how to model data, how to find the first several terms of a sequence, so they build up as we go along. Now, what students will be skilled at are those higher Bloom's kind of questions and skills, being able to analyze, apply, investigate, model. So keep those higher level terms in your mind as you're planning, because we want to know what the students should be able to do with each part of this unit. Specifically looking at arithmetic and geometric sequences and being able to tell the difference between them, being able to use formulas to define both sequences recursively and explicitly, and using the correct notation, recognizing the key concepts and describing characteristics of functions using domain, range, even and odd, symmetry, continuity, end behavior, asymptotes, critical points, in order to use those representations of graphs. Modeling real-world situation and being able to move fluently from tables to graphs to verbal descriptions and also symbolic notations in algebra when we're looking at functions. So keep these skills in mind as we go through the rest of this unit. Now, this unit ties directly to two content areas I've highlighted, language and literature, so that could be your 11th and 12th grade English classes and also the physics classes. In their English classes are organized logically as they look at repetition and patterns and transitions within novels and poetry. You can talk directly to your English teachers and see how they do that. You can make a connection in your class as you're talking about, sequences and series, and being able to recognize the patterns and structures that we see within each type of sequence, and using those patterns to look at them geometrically and algebraically, but making that connection to your English class makes their brain make those connections better and more solid as we look at these types. Similarly, in the physics classes, teachers guide students to talk about characteristics of the scientific method and the keys to recognizing patterns of changing and how patterns or characteristics change based on the scientific method that they're looking at. In pre-cal, we study both function characteristics and algebraic patterns in real-world situations, and you can tie this directly back to your physics class and maybe collaborate with your physics teacher on how to do that within your class itself. But always keep in mind that you want to make those connections to build their understanding across curriculum, that these words and these definitions that we're learning are not just solid within pre-cal itself. Now, our unit project is based on sequences and series. Students will need to come up with two examples, one a geometric example and the other one being a algebraic or arithmetic sequence or series that is coming directly from a real-world situation. Now, I've provided a numerical rubric and also a categorical rubric that you can use to grade these projects, but students will gain knowledge of the process to analyze patterns and characteristics of real-world series, and this might be a real good way to tie in, maybe buying a car or understanding what happens with a sequence as we move through a real-world situation. So let's go ahead and look at a project example and see what it looks like. So the reality series itself in this one is done by Anthony Bradley, and he put together a PowerPoint project that looks like an introduction of what the project is, how the sequences and series are defined, the example of an arithmetic sequence and a geometric sequence and the differences between them. He goes through and defines his arithmetic sequence. He did an automobile and the depreciation of the car as we go through it. So he gave an example. He looked at a contract, a real-world contract. He noticed the pattern and looked at the common difference. He laid out the formula and then made a graph of it. Then he did his geometric sequence, made his understanding of what it is and how it relates to cars and the change in the retail price. So here was this example, calculating the appreciation and percentage of a vintage car over the years. Started out at $50,000 and a appreciation of 30%. Somewhat realistic. Laid out his table, defined his sequence using a formula and the amount of interest you paid over 6 years, and then did a graph to show it. So you can see how they use specifically arithmetic and geometric, a sequence of both. And then he made his reflections about the project itself. So this was an example that is also on the project sheet itself. So let's think about backwards planning. In our approaches to learning, we have communication, critical thinking, collaboration as our highlighted approaches to learning. We want students to give and receive meaningful feedback, make inferences, and be able to draw conclusions about sequences. Critical thinking, they should be looking at multiple perspectives, whether that's a table, a graph, or maybe looking at multiple perspectives of each other, of how they've interpreted those graphs and data. Collaboration, we want them to be able to talk about how to find a sum, but also building consensus around and listening to each other's ideas about maybe function characteristics and how those characteristics can be seen within each of our parent functions. Now, I've laid out some learning experiences and teaching strategies that you can go through as you're building out your units and daily lesson plans. Scholars will spend a lot of time collaborating on different tasks. They will look through the different challenges of patterns and giving each other feedback throughout this lesson. So you can use group discussions, individual work times, quizzes, worksheets, peer feedback on different problem solving ideas. We really want to focus on investigating parent functions and a sorting activity at the end of the unit as a review. Scholars will discuss and understand the differences between arithmetic and geometric series and sequences. They'll need to be able to work together on these projects, or you can have them do it individually. We want them to create Pascal's triangle when they're talking about binomial expansion. If you have whiteboards or individual whiteboards, it's a good time to practice writing formulas for an arithmetic or geometric series. Of course, using the calculator to find explicit sums for series and being able to teach them how to do that. Specifically, I've used the catch and release model on function characteristics when we're identifying max and min's intervals of increasing and decreasing and symmetry. They also need to make inferences about domain range and what it means for a specific function. So those are just some ideas for you to think about as you're planning your lessons. Our unit assessment, of course, we have our projects. I would assume that you would want to use daily exit tickets to check student mastery and give feedback on a daily basis. I have done cumulative quizzes in the past so that each quiz builds upon the next, and then you can get a better idea of the understanding and mastery of each student. Here's some differentiation ideas. Let them choose their own problems for their project. If you have to give them hints, have them look at different commercials and understanding of how to buy a car or what the stock market's doing. Give them something to, really invest in. Students who are behind in understanding arithmetic or geometric series, give them some one-on-one feedback time, go through tutorials with them. A good website I've used for some differentiation is geogebra.com. You can look in modeling sequences visually. They have really good resources on looking and seeing the differences between arithmetic and geometric sequences in a more graphical manner. Make sure you're monitoring their progress and working with students on a daily basis to give them feedback on their understanding. Some specific real-world connections within this unit. Financial calculations, we're looking at mortgages or annuities. Understanding the medication within a bloodstream and how it increases or decreases over time and the effectiveness in the body. Text messaging based on functions of a phone bill, that may have been a better connection when we used to have those kind of phone plans, but the textbook still has those type of questions in there, so you might want to relate that back to them. The unit test is, laid out traditionally. We can take a look at that right now. So the unit test is basically made up of about 17 questions, 3 free response, and the others are multiple choice. They're going to need to look at what a sum is, how to write a recursive formula, what is a function, how to find the sum, Of course, you have the opportunity to change this test or modify it to fit your students, but I recommend that this was backwards planned from the CA, so I recommend using it within your unit. So our daily lesson plans, there are 8 lessons within this unit. We're going to start off with sequences and series. I have given you a annotated model lesson for day 2, and that goes through finding the arithmetic sequence and sum of that type. They need to be able to look at the formula, write the equation from the formula, find the sum using the formula, and you can see that they're looking at recursive formulas and also being able to use it in a more abstract method itself. So we build from arithmetic to geometric, whether it converges or diverges. Day 4 is based on the combination of binomial theorem and being able to expand it. This is good use of the Pascal's triangle and showing that. It is not a high leverage skill, but it is an important skill for them to use and be able to look at those patterns and make it to connections to functions. Day 5, we look at what is a function and its relations to domain and range. Day 6, we look at max and min's increasing and decreasing in symmetry. Basically the key characteristics that we follow throughout the year. Day 7, we look at asymptotes and end behavior. And day 8, they look at all 12 parent functions. This is a good time to use a sorting activity. I've posted several examples of sorting activities on the Blackboard. So as you plan your lessons, make sure you go back and look at the connection to the unit plan and the project. You'll notice on day 2, you might want to introduce the project, and then this would be an outside of class project. If you want to make it in class, make sure you budget more time for that within your lessons. So if you have any questions as you are planning, make sure that you refer back to the unit plan or the scope, and also feel free to reach out to me. I hope that you have a great start to the school year, and I look forward to seeing you on Collaboration Day.